podcasting from Lund, Sweden, home of the Nose Academy, a collection of 100 plaster casts of noses belonging to distinguished Scandinavians, and one of the most advanced laboratories in the world, Max 4. This is Intronauts, bringing you inside the Max 4 facility, where you get to meet some of the greatest minds and the explorers of tomorrow. I am your host, Toril Kornfeldt.
And I'm your co-host, Laura Roster, and today we will chat with a true visionary, Ian McNulty, director of Max 4, and we'll learn about his ambitions for Max 4 50 years from now.
Ian, so nice to have you here.
Thank you, it's a pleasure.
So you've been working here for about a year and a half?
A year and a half now.
And you had quite a rough start, didn't you?
It was a wild ride. In fact, my job changed in just a few months from physical sciences director to interim director.
And you also had some problems with the actual facility. The experimental ports for the measurements, the beamlines had been significantly delayed, and you had to scramble a bit to get started. What was that like?
That's an accurate description. When I arrived, we collectively learned that many things were behind schedule, and we had to really get our ducks in a row and start to prioritize very carefully and roll things out one by one, priorities 1, 2, and 3, and on down the list. We have been doing that, and the last year and a half, although it's been really hard work, has been quite rewarding. I think you'll agree Max 4 has made a lot of progress in that time.
Yeah, so are you up and running and on schedule now?
We are. If you consider the schedule clock starting about a year and a half ago, we're doing very well. Of course, thinking back several years, we're still behind on several projects. Some of the latest projects have just joined the fold in December, so those last year, so those are actually on schedule, and those are not delayed. We hope to now have a very reliable schedule going forward, and so far, everything is working.
That's nice. So how does it feel now that you both have tackled some of the problems and settled in a bit into your role?
Good. It's always, there's always something new. I am never bored at work, which is one of the reasons I like this work. But we have a bit of a routine now. Things are more steady state, a little less firefighting, and that's a nice place to be. So
you mentioned that it's a really varied job. What motivates you? What motivates you to come here even in the really grey, early Skåne mornings? So the thing that drew me here and still drives me every morning, every evening, is Sweden has taken a very bold step to plan a very visionary facility, Max 4, building on 30 years of experience with Max Lab to what now is the current synchrotron radiation research facility it is. That drew me here. It's the first of its kind, so-called fourth generation, so-called diffraction limited storage ring. There are others getting on board, and some funded projects already are starting to begin running elsewhere. But Max 4 is the first that has the lead, and this is why I came. This motivates me. It's the most exciting place to do science with X-rays. I mean, now you work as a manager, so you don't sort of are into specific projects, even though I know you have a science background. Mm-hmm. How excited do you get by the specific science projects that goes on around here? I find them incredibly exciting. I live now vicariously in terms of science through the team. I don't do hands-on science, but I get great pleasure, draw great pleasure, and no small bit of pride in seeing our team produce science with our user community, enable the facility to bring the research community to the point of doing very good science. That's a very rewarding job. And when you think about the contribution to society with Max 4, how do you imagine that the message is spreading about our work? So as you may know, Max 4 is involved in a very diverse portfolio of research, from healthcare to environment to climate change to energy science, material science, lighter, faster, quicker communicating materials. These are all things which, although they're at the fundamental research and basic research level, will lead to applications in many regards that will benefit society. And there's one thing I've been really wondering when we've been here. We've been talking to a lot of different people who work here and the scientists. So basically Max 4 is this big piece of equipment. And scientists from all over the world can come here and use this piece of equipment for their research. So how do you choose who gets to use the facility? That's a great question. Perhaps a good analogy would be the Keck telescope or one of the big astronomical laboratories. You have essentially one instrument or one with a few different bells and whistles.
And we have a peer-reviewed system which enables people to submit proposals. They lay out their case for doing good science with this facility. It's ranked by peers who hopefully are doing this objectively and consider the absolute quality of these proposals for science, and the best ones get time.
So how many questions or how many proposals do you get in?
Another good question. Just in the last 2 6-month periods during which we accept proposals, rank them, and allocate time at the facility for them, over 200 for each 6-month period. So about 450 in 2019 alone.
And how many get chosen?
Much less than that, about 1/3.
About 1/3.
Yep.
So how much time do you get? Like, do you get can I have a month? Or do you get yes, you can get 2 hours on the afternoon of Tuesday, November 3rd? Or
This depends widely on the science. Some experiments will run in just a few minutes, but typically a few hours at the fastest for a measurement, and then you go away with your sample and your data. Others might take a week or even 2 weeks. But it is also pretty common for experimenters to come once, twice, 3 times in a year to do successive measurements.
And how many beamlines at once can be running for these experiments?
So the beauty of these ring-shaped facilities like MAX4 is you have many beam lines, they call them, radiation pipes, like spokes in a wheel. Currently, we have 16 funded projects. We have plans in store for another 2 to 3. We can have up to 28, maybe, 26 to 28 maximum on the 2 rings at MAX4.
And so you are trying to be a manager for all of these projects, all of these scientists coming in here and going. I imagine that everyone here, every scientist that come and use the equipment, and also everyone who works here, thinks that the part that they are working on is the most important and is the one that's going to solve the world and sort of be the really fundamental thing. How do you, as a manager, deal with all of this?
You're very astute. That's often what happens. And we want to encourage that too, because they're motivated. These scientists are very motivated, both the users coming in and our staff on board, to push their scientific efforts very far as they can, to stay at the frontier of science. But at the same time, and I think this is really my role, is to set a vision, look at the big picture, and help our team, as well as the user community, secondarily, understand where should this laboratory go as a whole. What is the best science to focus on? What can MAX4 do uniquely and best? And not try to compete with other facilities that might do other things better.
So as far as looking at the future, if we look at the near future, say a decade or so, how do you imagine these light from MAX4, how can it be used to solve some of these bigger challenges, these global challenges that we hear about quite often in the media, for example, for medicine or for environment or for energy issues?
So already underway, but you will see, I almost can guarantee you, I won't say 100%, but it's very, very likely, you will see the outgrowth and the results of work going on now in battery science, newer, lighter, more recyclable batteries that carry more stored energy. Imagine laptops, for example, that you charge up for an hour and they stay charged for an entire year. You don't have to recharge your phone or your laptop every day. This is one kind of result that can come out of this basic research here at MAX4. Healthcare is perhaps even a bigger area, medicine and healthcare. You may know well that 1/3 to 1/2 of the scientific output of these synchrotron facilities, like MAX4, is in structural biology, learning the structure of protein molecules, enzymes, binding sites, and so on, which can benefit the pharmacological industry, the drug industry, and therefore medicine and healthcare.
And you mentioned earlier that there are other labs that do interesting things as well. Just quite next to us, basically, just a few 100 meters away, there's another facility being built, the ESS. And I think a lot of people looking at these 2 labs, the ESS and the MAX4, will go like, aren't they the same thing? Aren't they doing the same thing?
It's a good question. In many ways, they are the same. They're both user facilities in the sense that their primary job is to serve the research community, to enable the community, Sweden first, the rest of the world second, to do groundbreaking research, in this case with X-rays at MAX4, but at ESS with neutrons. The big difference is neutrons are very good for looking at the lowest weight, lowest density kinds of matter, hydrogen, water, plastics, things like that. X-rays are better for looking at the heavier elements, the more dense materials in metals, iron on up, and so on. There's a lot of overlap. These are not exclusive. Some of the same things can be done at both facilities, but what they provide is complementary information, often about the same kinds of materials or biological cells or systems that you might be interested in.
So do you see in the future a lot of the scientists coming to Sweden doing projects both here and at the ESS at the same time?
Yes, indeed. In fact, we envision perhaps a common portal for submitting proposals that might involve an experiment at ESS with neutrons and one at Max 4 with X-rays, perhaps on the same visit of a week or two that some user team, some research team comes here to Skåne to do the work.
You mentioned some of your thoughts about the science that will be developed here. How do you see the facility evolving in the future? Where do you think Max 4 will be in say, start with 10 years?
Because of this amazing ability for this type of facility to serve 25, 30 experiments simultaneously, you can expect to see rapid growth in the number of experiments that are carried out, results that go into publications, and from that, a smaller fraction, yes, but some of those that really go into things that really benefit society. So right now, I mentioned we have had about 450 proposals. We have about 700 users who are engaged in writing these proposals just in 2019, last calendar year. But I expect that number fully within 2 or 3 years to be close to 2,000 users. And annually, we expect to see that many cycling through the facility and delivering science. The scientific papers that come out, although the details may be very technical and uninteresting to many people, show that because they've been reviewed by peers, other scientists around the world who consider them to be credible, underlies the credibility of the science that comes out of the facility. And the number of those scientific papers that come out, which could lead to real applications, will also grow. We can expect perhaps 500 papers a year out of Max 4 by 2022, 2023.
And as far as the structural growth or potential of Max 4, how do you see that in the near future?
Currently, we have 16 funded beamlines, I mentioned. We can grow to about 26, so we have room for 10, maybe 12 more. Right now, we have to make sure that we can deliver all the planned capabilities and operate what we have as fully as possible to exploit the full potential of the facility. But because the planning for new beamlines, new projects for more experiments at Max 4 takes a few years, and the delivery and construction of these also takes even more years, 5 to 6, we should also be allocating some time to plan for that. So we're doing that. We have a vision for building out the rest of Max 4 to really extract the full capability of this considerable investment.
So we've already learned in this podcast that all of the beamlines are different. They can answer different types of questions. They can investigate the world in different ways. So what kind of beamlines would you like to develop in the future? What do you think you're missing right now?
Very good question. So one thing we've had an eye on for some time, and our medical community just here in Sweden, but also worldwide, is quite interested, would be a medical imaging beamline, one that can be used to study not full-size human medical subjects, probably just up to the size of mice or maybe inanimate things also, which are of medical interest, like bone structures or materials for prostheses, but systems up to something like a cubic centimeter in size, where we want to know the 3D structure without having to cut them open. So it's a kind of medical 3D imaging, but at the micro scale. Microtomography is the methodology. This is a beamline which we know would be very heavily used and produce great science and really have direct impact on things like understanding of the structure of teeth, bone, heart muscle, and so on.
Podcasting from Lund, Sweden. Do you have any specific sort of dream projects, questions that you hope scientists will try to answer here, or future beamlines that might be able to answer some sort of scientific questions that you really think a lot about?
I do, but promise to keep them here in Sweden because we want to be the first. One of those areas which has me very excited, it's very long range, is an area that people may have been hearing about known as quantum materials and quantum sensing. Max 4 is very good at producing what's called coherent light, where all the X-ray waves come in step, like soldiers marching in formation. And if you want to study the smallest structures and the most least size changes in the state of matter at the quantum scale, you need coherent light. That's really the proper tool to have. We can do that better than anybody else right now. What can these be used for? If you want to build electronics that use extremely little power or communicate in completely unhackable ways, quantum technology, quantum computing based on quantum materials and systems does look like the most exciting avenue.
So we've been talking about sort of a 10-year time frame. Looking a bit further into the future, where do you think Max 4 will be in, say, 50 years?
50 years. That gives me a chance to really dream. Currently, right now, we have 2 rings and a linear accelerator that serves those rings. And not much else is out here besides a construction site at ESS and the comparative medical unit going up by medical faculty next door. In 50 years, I imagine this will be an extremely vibrant community with maybe several rings, Max 5, Max 6, maybe Max 9. We'll have an X-ray laser or 2, which will be used to probe matter at the very shortest and smallest timescales you can achieve, as well as rings which can serve many experiments at once. This community will serve the scientific interests and technological interests of Sweden across a variety of areas, again, healthcare, medicine, climate, and energy. And we'll look back on this time and think, wow, that was so cute, it was so quaint what we were doing in 2020. And now we're onto the real problems, and we've made huge strides in solving these challenges.
Yeah, you've touched upon it, but what kind of global challenges and what kind of global solutions do you think that Max 4 can sort of contribute to solving or making the world a better place?
Well, let me give you some specifics. As we know, just in the last few weeks, novel coronavirus is a scourge that has a lot of people worried. It's spreading rapidly. We already know the structure. We have a bit of understanding about its infectious progress. What we don't know is what can be done to treat it or cure it. Understanding that structure and what systems can attack it, what systems can disable the virus, are directly things that Max 4 and facilities like Max 4 could contribute to. So that's a current issue of current concern. But attacking disease on many levels is something, again, Max 4 could make a big difference in. Another example could be type 1 diabetes. We know systems, this disease involves mishandling of insulin. We know the structure of insulin. It's been around for some 60 years, that structure. But we don't know yet how to cure the disease. We can only treat it. That would be a wonderful thing. It's a grand challenge, but it's something, again, Max 4 could treat or work on.
One of the things that I find really, really fascinating with Max 4 is the fact that you have all of these scientists coming in from different parts of the world, working with very different projects, but then sitting sort of next to each other up in the fika room in the dining area. And I imagine there's a lot of area for sort of synergies and new sort of development just by people meeting. Do you do anything specific or special to sort of facilitate those sort of informal meetings between scientists?
We do. Science is really a global effort, and I believe one of the key reasons it makes an impact on society, that we benefit from all the things technology and healthcare give us that we didn't have 5, 10 years ago, let alone 100 years ago, is the ability for scientists to communicate quite freely across boundaries, across disciplines, which often can be challenging, but across national boundaries, community boundaries, university boundaries, and this kind of thing. Sure, there is competition, but it's generally quite friendly competition. And this concept of peer review, where you seek credibility and ratification of the quality of the work, the believability of the work from one's peers, is an important part of that, essential part of that process. So we work quite hard here to enable that. It's not any different, really, than you find at many universities or other laboratories, with conferences, seminars, participation in international meetings, whether it's by video link or actual visits abroad. These kinds of interchanges in communication are crucial. We also have a lot of informal meetings, and I can't tell you enough how much work gets done just across the coffee machine or at the water fountain.
So this concept of fika is very useful in Sweden.
Extremely. It's very valuable, and coffee and tea, I should say, are the things that fuel us.
I can imagine. Thank you so much, Ian. It's been really, really nice talking to you, and it's going to be interesting to see how Max 4 develops in the future.
Thank you very much. It's a pleasure.
Thank you.
Thank you so much for listening to Intronauts with me, Toril Kornfeldt, and Laura Raster. And if you like the show, please leave us a nice review on iTunes.
Yes, please do.